Okay, next we're going to speak about Netflow. Let's see again what Netflow is, how do we configure it on both the ESA and the iOS. So by the name, it allows collection of flows from the network, mainly flow statistics from all traffic, or of course you can also restrict if you want to see statistics for all traffic going to a device or only for specific traffic. But in the end, it's going to be flow statistics about some kind of some traffic or all traffic which goes to the network, to those devices which are going to be Netflow configured. Likewise, like in any other technology, we have some roles in there. So one is going to be the flow collector, which is going to be the central system, that application responsible with the receipt, storage, and interpretation of the flow statistics, to show you those in a graphical format, so you can have statistics about what happened in the network, who sent traffic to where, and what kind of traffic. And the flow exporter is which is going to be a network device, which is going to be aggregating the flow statistics and exporting those statistics to the flow collector. Now, Netflow was developed by CISCO, which means there is no standard RFC which has been written. CISCO, of course, has written some information RFCs to let let's say everybody know how Netflow works on CISCO devices. And if anybody wants to implement Netflow, they're going to have in there enough information to be able to also implement Netflow like other vendors. Now, by default, it runs over UDP 9996 port. So the exporter is going to send to the collector statistics over UDP port 9996. Of course, that can be changed on both the exporter, the network device, and on the collector. If you want to use a different port number, or if your collector uses a different port number, then of course you gotta make sure that in between the exporter and the collector, the UDP port number matches. Now, because this is not a standard, other vendors have also developed their own version of Netflow, because clearly it was obvious that Netflow, it's a very useful tool, not only for security reasons, but also for network monitoring. Couple of vendors in here, it's a lot of them who've developed their own version, like Juniper uses JFlow, probably from Juniper Flow. HP and Huawei uses NetStream, or for example Citrix uses AppFlow. Now, SFlow seems to become a standard with wide vendor support. So SFlow is starting to be supported by a long list of vendors. So pretty much it starts to be like a standard in there. And of course, all of those implementations, JFlow, NetStream, AppFlow, SFlow, all of them pretty much are, let's say, derived from the Netflow protocol, which was developed by Cisco. Now, as I stated before, Netflow from a security point of view is useful because it can detect attacks to network flow behavioral changes. Like as I stated, if, for example, usually in our network, when we do a baseline of the network, we know that this server, for example, has never sent any kind of, let's say, HTTP traffic out to router 3. So as soon as via Netflow we detect that that server starts sending HTTP traffic to router 3, that raises a question mark, because that's unexpected. So unless we have configured that server to actually send HTTP traffic to router 3, it could be an indication of compromise on that host, which sends, let's say, traffic which it shouldn't be sending out in the network. And likewise, it's the same thing. It identifies network flow anomalies. So whatever is suspicious going on in the network, Because as I stated, nowadays it's very difficult to actually chances are that a very good developed malware, it is going to bypass pretty much all of the security functions or protocols or devices you have in the network. It's going to reach its target, and of course it's going to start doing damage on that target, which means that for the once the attacker is on that end host, it means that in order to do its job, to to grab its hands on some useful data, it means it's going to start discovering the network, or it's going to send some traffic to a specific destination in the network to gather some data, which means that that's going to be a suspicious or abnormal traffic flow, which Netflow is going to of course detect that and send that statistic to the collector, and you're going to be able to quickly identify that there's something weird happening in the network in there. Now, several flow information can be collected by the network device, but most importantly, the network device is gonna send over to the collector for each let's say each packets for all traffic transiting that network device. The network device is gonna collect statistics about each flow, and it's going to collect the IP protocol number, like was that ESP, AH, GRV, what traffic was that, what is the protocol number, what is the source destination IP addresses, because you want to know like who sent that traffic, what is the source and where, out to, what is the destination. The source destination TCP UDP port numbers to see exactly the service that that client was trying to access. The IP marking information, so for QoS, the layer 3 marking information, and also the ingress interface. So you need to know a direction, like on which interface was that traffic flow received by that flow collector, by that network device. Now, Cisco has developed, of course, multiple versions of Netflow, because as additional capabilities have been added to Netflow, a new version was released. And commonly the versions are going to be 1, 5, 7, 8, or 9. While most commonly deployed is going to be version 5, which is pretty much like the standard in Cisco. But then except version 5, pretty much nowadays we're going to be using version 9. So in general, in a Netflow, let's say implementation, you're going to have version 9 or version 5 or version 9 used. Of course, both the collector and the network device have to support the same version, 5 or 9, because based on the version running, then different formats are being used for the flow statistics, and of course additional information are being contained in the flow statistics, which means the collector, the exporter, has to be able to collect that data, and the collector should be able to interpret that data. Now, one of the main advantages of version 9 is that it supports flexible Netflow. So what that means is that, for example, let's say that in our network we're gonna configure ASH3 to be the exporter, the flow exporter. So the device which is gonna collect that traffic statistics is gonna send that data over to server A, or server A is gonna be the collector. So what this means is that with version 9, what we can do is we can configure the ESA, the exporter, to collect statistics only about traffic from, let's say, VLAN 91 to VLAN 90. So we're flexible into what kind of flow statistics do we gather for which kind of traffic, and also what information about that traffic do we collect the statistics to send over to the collector. That's one main advantage of version 9. And also it can gather statistics about additional fields, additional protocols. For example, it supports multicast, flow statistics, MPLS, and also other technologies in there. Now, configuration wise, on the iOS, it's 3 main steps, 3 main blocks. So we first go on the iOS device and configure flexible Netflow exporter, which means we define who's the flow collector. So where do we export the data? and what is the Netflow version which we're going to use to export that data, those statistics. Then we configure what is called the flexible Netflow monitor, which means, as the name states, what do we monitor? So again, the blocks make sense. So where do we export the statistics? Like, what is the collector? And what version do we use to export those statistics? And then the monitor means, what do we monitor? What statistics do we gather and for which flows? And then of course we bind under the Netflow monitor configuration the configured exporter. It makes sense because we want those, what we monitor, we want to tell the router to who to export that data. And the last step is of course to enforce the actual gathering of the Netflow statistics by applying the monitor, which the monitor says what to collect and for which flows, to a interface of that device. So it's very basic and it makes sense. We go on Router 2, and first step we define the communication with the collector. That's step number 1. Step number 2, we define what to collect. So what do we want to collect? What do we want to monitor? Which flows do we monitor to get statistics, and what statistics? And we bind the collector to the monitor because those statistics we want to export them to that collector. And the last step is to apply that monitor, so to enforce the monitoring of that to the gathering of the flow statistics on which of the interfaces on which of the router's interfaces, on this interface or on this interface, wherever we want. Of course, we can apply the same monitor to multiple interfaces. Now, of course, production-wise, like for example, if we go to this example in here, if let's say that this is our network, which means router 1 is our border router. So clearly, in this direction is going to be the internet, for example, the internet. Which what this means is that on router 1, pretty much all traffic is going to flow both ways through those two interfaces of the router. So there's no way that traffic is going to flow this way coming from the internet and going back out on the internet because we're not a relay for the internet. And there's no way traffic is going to go inbound on router 1 in here and be routed out on the same interface. Which what this means is that we're going to apply the monitor either on this interface or on this interface, but not on both of them. Because if you applied both of them, the same session flow could be sent 2 times to the collector. It doesn't make sense. It's redundant information. Verification wise, we verify the exporter configuration, show flow exporter statistics, show flow exporter with or without statistics. The command makes sense again. We want to verify, show me the flow exporter configuration. What is the collector pretty much? Have I defined the collector and how have I defined the collector? And then verify the get statistics, which is via the monitor, let's say, a function, which means show flow monitor to see, okay, how have I defined a monitor and what statistics have I gathered for which flows in there. From the ASA point of view, it's going to be pretty much the same 3 steps, but it's going to be a different configuration because ASA is a different platform. So first we define the exporter. Likewise, we define out where to which collector do we send the statistics. And the ASA supports only version 9 of Netflow. And then the way we monitor or we get statistics on the ASA is via the modular policy framework configuration. So we go and we configure a regular modular policy framework. We do a regular modular policy framework configuration, and we define which statistics to collect for flows. And then of course we bind the configured collector in there, the same approach as on the iOS. And finally, we have to enforce the gathering of those flow statistics by applying MPF either globally or per interface like any other regular MPF configuration on the SA. Verification wise, we verify the Netflow exporter because that's done via the MPF show service policy, and we verify the Netflow export statistics via show flow export counters in there.